Hello, perfectionists. Welcome yet again to another Prefect Live. I'm back this time with man, myth, legend, all around good guy, terrible keyboard takes, Kevin Kho.
Sorry, I had an echo because I had Twitch on. Hey
Yeah, no worries.
everyone. Yeah, I am Kevin. I am an open source community engineer at Prefect. For those who don't know me yet, um, and yeah, am I gonna say what I'm gonna be talking about today? Or
Yeah, let's well, I
yeah,
mean, at first I figured we could banter a little bit, I guess, Kevin, a little.
okay.
Sure. Yeah, let's why don't you tell us what we're gonna be talking about, then we'll banter, and then because I've got some bones to pick with you, and then we'll go and we'll do the thing.
Yeah, so I'm gonna be talking about data frames in general. So pandas, Spark, Dask,
Mhm.
and my side project Fugue, which is an abstraction layer on top of all these three. So we're gonna talk about like also the other like hey, just change the import, and we're gonna take your code from pandas to Spark or pandas to Dask. We're gonna talk about that as well.
Nice. It sounds really exciting. Okay, so that'll happen. First thing, and we got some people active in chat already. Talk to me about not using the number pad for keyboards.
Okay. So it's actually the last time I was here on stream, I was showing this keyboard,
There it is.
right?
What?
But
Hold on. What is up with the F row? What are
the oh
that's
here,
amazing.
but you can press them. You can press them.
Yeah, that's awesome.
But then yeah, I mean, since you're calling for it, I have a new keyboard.
Let's see it.
Let me just change. This one has no letters,
That's elite keyboard.
so
Elite.
we can, and then it RGB as well,
Oh, but it's
and
just
then
oh, that's cool.
yeah.
Yeah.
So I am getting broker and broker. I get more
Yeah.
broke. I'm getting more broke
Right.
every month on these. But yeah, I have a new keyboard. This one I have so many typos, but we'll just try it out for
Would
this stream.
you consider yourself the biggest keyboardist at Prefect? What would you
No,
say?
no, I just started. It's Dustin or Jean because Jean actually has. I mean, like he actually also buys things and then like gets them 1 year later. I
Mhm.
haven't done that kind of model yet of buying stuff,
Oh,
keyboard
like
parts. Yeah,
the super custom
yeah,
ones.
yeah,
That's
yeah.
funny. And last thing, we'll get to the stuff, right? But I just love having Kevin on, recurring guest. Talk to me about the background we've got on right now. Was this what's this mean to you?
Oh, it doesn't mean a whole lot, but the background is Dexter. Is anyone asking? The background is Dexter's Lab. I spent too much time as a kid watching TV. That's
Yeah,
pretty much it. Yeah, a good 4 hours a day.
same. Were you obviously a Nickelodeon? This is Nickelodeon, right? Dexter.
No, he's Cartoon Network.
He's Cartoon Network.
Yeah.
I was unlucky enough to not. I didn't have um, cable growing up. We had 6 over the air channels, so I didn't get to watch Dexter. I was more of a PBS kid, which my fiance Julia always makes fun of me for. Okay, cool. Let's get into it. I just wanted to check in on what was unique about this time having Kevin on. Okay, we've got your screen up, so we can see all that. Let's get into it, and hopefully you don't mind if I F in chat.
Oops.
F in chat for me, Peyton. But I hope you don't mind if I interrupt you and ask you a ton of different questions.
Yeah, 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 and just interrupt me if people in the
Yeah,
chat ask
your
any
screen's black. Your
questions.
screen's black now, by the way.
I let me reshare.
Oh, okay.
Yeah, is that good now?
Yeah, hold on. Let me see. Let me fix it here. Kevin. 1, 2, 3 looks good.
Okay, perfect. Okay. So for those who don't know, I have another open source project I'm involved with called Fugue, and Fugue is an abstraction layer over Pandas, Spark, and Dask. So we're going to be talking about Fugue today, no prefect. And Fugue is also, I will be in PyCon next week, and my topic will be about Fugue. So if anyone out there is going to PyCon, feel free to message me so we can meet up. So
Just
yeah,
I
we'll
just put the few docs in chat too. I think they're the right ones. I'm pretty sure. And then
let me check. There's
yeah,
another Fugue.
Yeah.
No. That's the other Fugue.
Yeah, wrong one. Sorry. I just after I hit enter, if I'm while you do that, PyCon and Prefect is hosting an event as well at PyCon that we'd love to have you guys at. I think it's going to be Friday evening, I believe. We're going to do a happy hour at PyCon at a brewery across the street. So keep your eye out for that. There will be an invite that goes out. And I'll find the real docs, Kevin. Apologies. It's called Fugue. It's called Fugue Sequel. Is that what you call it? Fugue Sequel, right?
No. I'm sorry, my keyboard is not working. Let me try reconnecting.
Yeah, no worries. It's Fugue Sequel though, right?
This Fugue tutorial.
Yeah, that's the one.
Now I can paste it.
Yeah.
Okay. So let's start with what Fugue is, and what we're gonna do is just go through the hello world over here. So we are going to make a pandas data frame, and this data frame, actually I'll just paste this from the README right here, so we can.
What's the 2 sentence of what Fugue is?
Fugue lets you define your code in Python or pandas, and then brings it to the distributed compute, like Spark or Dask for you.
Awesome.
Right. Maybe we need a primer on distributed compute as well. So let's talk about distributed compute. I'm sorry, I don't have letters. Here, so I have this image here, and this image is a Dask data frame, right? So pandas doesn't scale across machines. Like when you use pandas, it's only confined to one machine. So if the moment your data exceeds that RAM, then you can benefit from using Dask. Or if like your computation is too expensive, you want to parallelize it, then you can use Dask, right? So the Dask data frame is a good example. It's a data frame that is built on top of pandas data frames. So each one of these blocks is like a collection of pandas data frames. So when we use Dask in Prefect, though, it's not tied to the data frame concept. It's just tied to the like native Dask, like the core Dask core library. But then there's that data frame collection on top of the core library, which handles the orchestration of like those like Dask futures for you and those Dask operations, right? So pandas is we have a pandas data frame as what is called a partition inside the Dask data frame, right? And so the important thing to note is that over here, I need a new image. The data lives across the workers, right? So this partition may live across this worker, and this other partition may live in another worker. So you don't have access to all of them at the same time, right? So that's one thing to note, and we'll talk about that later. But the important thing for now is just to show the current Fugue interface. So the interface changed like a couple months ago, and similar to Orion, where the priority is now incremental adoption, Fugue became a lot simpler to use. So we're going to show the Hello World example of Fugue.
Inspired.
So
you're inspired.
So we have a data frame, this input data frame, and I'm just going to show what it looks like. There's an ID, there's a value, ABC, and our goal is to make a new column called food, and it's going to be like if the letter is A, we're going to put apple. If the letter is B, we're going to put banana, right, and so on. So what we're going to do is in pandas, I think you can just do something like this. Input df dot map mapdict. Maybe something like that. Oh no. No. Is it no, I need to look here. Yeah, it's dot. Oh, okay. Input df our letter, a value dot map. There we go. Okay, so now we have it. But the question becomes like, hey, let's say this data frame is really big now. How do you do the same operation on Spark, for example, right? And on Spark, we can take a look at it. Spark, new column based on dictionary, let's say. And what you're gonna find here, this is the exact use case we have. And what you're gonna find is that the basic expression is something like this. So you import PySpark. This is the dictionary. You use this. I don't even know what chain does, to be honest with you, but I don't use it often. But the point is, you have to make this mapping, and then you make this mapping expression, and then you apply it, right? So now the syntax between pandas and Spark is very different. So what happens now if you have a pandas project and hey, my data is getting too big, I have to move to Spark. So for the exact same operation, you have to rewrite, basically, right? So that's one of the advantages of Dask, in the sense that in Dask, your rewrite should not be as bad. Maybe it will just work. I'm not sure. Let's try. Dask dataframe as DD, and then we can say D from pandas input df, and then maybe we can try this same operation, ddf, and then we have to use compute. And let's see if this works. No,
Nope.
Excuse me. Exactly. Oh, okay. So if you make a data frame from pandas, you have to supply a number of partitions. Am I just what was? There's no
underscore.
Yeah. So we say and partitions is 2. So this works actually, and it's fine. So for between Dask and Spark, like the bar to move your project from pandas to Dask is a lot simpler.
That's like that's the whole value prop of Dask, right? Is that that's what they want. That's what they want. I mean, but exactly. I think it might be helpful too for people who don't have a background on Spark and in Hadoop in general to understand that. So Hadoop was brought about as big data computing framework, not super performant, and so then 2011 or 12, and we'll talk about this actually. Plug for PrefectLive. I think in 2 weeks with Bill Palombi, we'll talk about the history of data flow automation in general. But then Spark comes along. Right. But Spark is Scala Java based programming. And so then when did Dask come along? Do you know, 2015, 16?
I think it's 6-7 years already.
Yeah. Okay. Yeah. So just there was, I think, a kind of a movement into quote unquote big data. I want to be able to handle large data sets at scale just because one huge computer can't do it. And the parallel computing, data warehouses and processing systems of the time were quite expensive. So you wanted to go to cheap hardware, scale everything out across cheap hardware. That's what Hadoop was all about. Spark kind of came along and just more effective at it, but a different programming language. And then that's what Databricks is built on. And then Dask has come along now to kind of do the same thing, but based on it's closer to Python. Just a little bit of background, I think a little bit of history.
Yeah, so it will be a lot easier because Dask on top of is still native Python, right? So it's
right.
You don't need to worry about what Java version you have or that Hadoop path or bin or whatever. It becomes a lot easier to manage
and even the syntax looks kind of funny in with Spark.
Spark,
and that's PySpark even too. All right.
Yeah, let's bring it up here. So this is PySpark. This is the PySpark syntax. So the purpose of Fugue is how do I not have to do this, and how can I use this expression, for example, and then apply it on a Spark data frame, right? Mm-hmm. So here's where we start with Fugue.
One more kind of positioning question, because this is what I'm kind of fascinated in. Fugue is the real value proposition that you can switch between, right? So you're used to writing in Python, but you're using your organization uses Spark today. You don't use Dask, or you're starting to use Dask. Is the whole point that you can switch between these things very easily? It's write once and then you can, the infrastructure is kind of invisible to you almost.
Yes, yes.
Okay.
I mean, you have to control your infra, but then you can. There's no lock into the framework that you're using, right?
Right.
So we get our code here to, I guess, this one. So let's map letter to food, and this takes in a pandas data frame. The output is also a pandas data frame. And then, and then we will just create this dot map dict. I'll take a map dict as well as a parameter. I think I may need to import that dict. Import dict list iterable. Okay, and then now we can return this df. So this is the same code we had earlier. It's just wrapped in a function. And now I can call it map letter to food. And then I can say input data frame. My input data frame is already corrupted though, so I may just, okay, it already has the food. What I'm gonna do is just create it again, like this. So input data frame, we don't have that column, and then we can say map dict. And we get this new column, right? So this function is now working. So now in order to bring it to Spark, what we're gonna do is use the Fugue transform. So first we'll just do it on the local engine. So we can say transform input data frame using map letter to food. And then we need to supply a schema because, and I'll talk about this more later why we need the schema, but in the distributed settings, schema is a requirement. So now we need to make it a requirement for local like execution as well, right? So that it's generalizable. So here we will have like food, which is a string. And I think this should be it. So we can do transform. Oh no, let's see what happened. Okay, it's just because we already had that the pandas data frame is like in place. It edits it in place. So what is the error now? Map dict. So I need params map dict and map dict. Maybe like this. Params. Okay, we're good now. So we have this transform, and this is still on pandas. But now in order to bring it to Spark, all we have to do is we import Fugue Spark. And then over here, we say engine is Spark. And this will apply this function on Spark now. It's going to take long because of the Spark spin-up time, the Java environment and stuff. Yeah, it's like 20 plus seconds.
Wait, above, you had Dask specified?
No, I had nothing.
Just nothing. Okay.
Pandas. Yeah.
Oh, so it just does pandas locally, right?
Yes, exactly.
Okay.
Exactly.
Yeah,
so,
without any without Dask being instantiated.
I need like this is because Spark is lazy, right? So nothing got printed. So you need .show. Oops. And then we have our data frame now. There we go. Right. So why do we have so many of this error? It's because this is a pandas data frame, right? I'm sorry, yeah, it is pandas right now. It will be converted to Spark, and then you have this function. This function, if you recall, is applied on a pandas data frame, right? So now what happens is we treat each partition, Spark or Dask, we treat each partition as a pandas data frame, and then we apply the function on that partition, right? So like each worker here will now apply that same function. They'll have some partition and they'll apply that function on that partition.
What if there's like any kind of like a join type of thing?
Join?
Yeah.
Join is a bit more there's a different interface because
because if it's across nodes, basically, right? That's what I'm talking about. Like, say data's living in different places because it's a distributed system. If you have to join across those, what happens?
Yeah. So there's two ways to think about it. Number one is like, hey, I'm just joining these tables. If you're
Right.
just joining the tables, you kind of have, we don't have one function like this. So when I told you the Fugue syntax change, the previous syntax looked something like this.
Mhm.
It was like Fugue workflow as dag, and then you say like df equals dag.create, and then maybe this can be dag.load as well, right?
Mhm.
And then from here, you can, I'll say like df2, dag.load, df, and then now you can say df.join df2, right? So this is the syntax for join.
Right.
But people didn't like this. Like now, this means that like in order to use a Python function here, it has to be a bit more strict. Here, let me show you. Um, like for example, it's like in Prefect, if you have to do something inside the flow, you have to wrap it in a task.
Right.
So if I get this function here, then I would have had to wrap it maybe like this. Oops. Uh, or okay, here. I would have to say transform, because it's and then this transform, I could now say df dot transform, map letter to food.
Oh, so and so the new one is the decorator. Is that right? The new format.
No, this is the old, and then it
Okay.
uses here. The new
Right.
is just one standalone function.
Got
Like,
it. Okay.
hey, I just have to incremental, right? Like I just have one expensive step. I
Right.
want to bring it out, right? So this is the newly exposed one, this transform function over here. So for join, it's like this. And then another one is what I'll we can go here. The other one is what is called a co-transform. So the co-transformer, um, this is not a good example, but the co-transformer is basically like I have two data frames, but then when I partition them to live across the workers, they're partitioned in the same way, right? So for example, you have a table of
Mhm.
like employees and uh sorry, no, like a good example is like time, right? Let's
Mhm.
say you have like prices, you have inventory for a certain ID, then you want those them to be like, I want the January stuff to go here and the February stuff to go
Right.
here. So you partition both of them by time ahead of time. So you cut, which is basically a join already though. So what it does is it joins beforehand and then
Right.
moves it to the worker, and then you apply your operation there, right? So basically, when you do this join over here, this is saying, hey, use the Spark join under the hood, use the Dask join or the pandas join, right? But it's unified such that you get the same behavior. And we can talk about that actually, because that's an interesting point as well. But before we do that, the next thing to just show is like, hey, I want to bring this to Dask. You just change your engine here to Dask. Oh, Dask is not show. Dask is head DDF dot compute dot head. There we go. Right.
Nice.
So we have this transform function, and this transform function is already very powerful, right? We can apply it on a data frame,
Mhm.
right? On all like Pandas, Spark, and Dask data frames, right? But that's not it. There's actually more to unpack here. So let's take a look at this function. And I showed you an implementation where I use .map, which relies on the pandas data. The pandas data frame has that property specifically, so I'm calling that pandas. But the philosophy of Fugue is like no lock into any framework,
Mhm.
so we can actually remove the pandas dependency from this as well, right? And to do that, I'm gonna represent things a bit differently. So my df, I'm gonna expect a list dict stir any, and I'm gonna output the same thing so that I don't have any pandas data frame. And now this function will change. Now I can say for row in df, because this is now a list. And then I can say row food is equal to it's a bit it's a bit different. It's going to be the map dict of the row value.
Why? So why would you take it out of pandas?
To show that, well, number one, pandas has some operations it's not good in.
Okay.
That like here, like I don't even need to know pandas. This is just a list in a dictionary, and I can like understand this code, right? So once you have this, I believe we should still be able to use this on this transform, right? So I'm gonna copy this guy, and we're gonna use the map to letter food 2. And then this is just df. We're taking out Dask first. So this is one of the things also, right? You can prototype on pandas very quickly. And then when you want to port it, you just change the engine. So let's try this. Df.head.
And this isn't intuitive to me because I would think that pandas would be, I mean, generally better at an instance like this, right? Where you're just
for this one, yes. But I can show you an example that's a bit less straightforward.
Got it.
Yeah,
Kevin's like, shut up, Chris, and let me show the example. No, yeah.
No. Let me pull one. Challenge accepted.
Challenge accepted.
I'll have to, let me see if I can quickly find it. Because that was exactly what we did in KubeCon, where we showed that kind of like, hey, this is something that's really really not friendly for pandas anymore, right? Let's see. If I can't find it in like the next minute, then I'm just gonna move on.
No worries. I should have some animations ready to like move around the screen and stuff. Any questions in chat? I see some of our regular customers and regular lurkers are here.
Are there any questions?
No. Henning said that the schema equals star was new to me. Nice. And I saw that it's schema equals quote, double quote star.
Yeah. So we can talk about that actually. So let's say you have this function here. If you don't supply the schema here, we can parse it from the comment line above. So we can say schema star food star. This is also a valid implementation, right? If you don't have this, then it will complain, hey, there's no schema. I don't know what to do.
That's
right?
really interesting, but you can just comment it above.
Yeah, so this comment is parsed as well. So that's one way that you can do this. And then the other way you can do it is you say transformer schema equals this. But then there's really no advantage to doing it this way.
Right.
Like I really highly prefer it. Again, like we want to minimize even your dependency on Fugue. So even if you drop Fugue, you just have a helpful comment, right? Unfortunately, I cannot find my KubeCon presentation, so I guess we can. So the use case I wanted to show though is like, hey, like pandas kind of has this assumption that you're in, not really, but then like, you can do stuff like, hey, I want to add across all of the rows, for example. So in that case, you can do something like a treat list, and then you can like add, across rows or across columns or whatever, as long as they're in the same partition. But then, yeah, I don't have that example ready. Okay, so we have this implementation, and then we can also do some other implementation as well. Like for this, we can say, let's try iterable over here. Iterable. I think that should work. And then over here, how this is gonna change the sealed row, right? So now this is a generator on the fly, and then this will be used as the type. I think this should work as well. If it doesn't, okay, it does. It still does. So this saves memory. It does it row by row, but in a memory, conserved way, right? So Fugue is the one that applies, like it's say, hey, there's a partition, and I'm gonna convert the data frame in that partition to list dict, and then I'm gonna apply the code, and then so you have to juggle a lot of this like type conversion. So it depends how you want to apply your logic, right? The last thing I'm gonna show is about this is Fugue SQL before we move on. So I'm gonna say from Fugue notebook import what is it now? Setup, and then setup. So what this setup does, I'm gonna move this up here. Don't need that. And then what this setup does is I'm gonna just change this again because this map dict is a bit. We can pass it in, but it's a bit harder. So I'm gonna change. I think this should be good. So I'm gonna go like this, and then over here I'm gonna make a new. I can't find. Okay, F equal select star from. We're gonna make a new input data frame over here, and then this input data frame we can use here. Input df. Transform using map letter to food 3. Do I have? I don't have. I'll define the schema because it's easier to define up here. Schema food stir.
So and I think you define a transformation function in Python Fugue, and then you're able to use Fugue SQL to basically like manipulate, interact with the data frame and use that transformation.
Exactly. So
wow.
Look at this. We can do df2 equals this. And then in the next one, we don't really need the select actually. Transform is already a statement. And then what we can do is down here, we can say select star from df2 where food, let's just try. I don't know the syntax if it's.
Is there a library called PySQL yet?
PySQL? There's no PySQL. Food
maybe,
is not defined.
Maybe you should call Fugue that.
That's, I mean, okay. So there is there's an abstraction layer, and the abstraction layer ports Python or pandas to Spark or Dask. So in Fugue, for Fugue SQL, it's built on top of the same abstraction layer. So the SQL gets mapped to one abstraction layer, and then it can choose the engine, right? So I'll change the engine in a bit. I just need to see why this is not working. One sec. So, okay. I don't know why this would, let's just say value equals A. This is more sure. Value equals A. Okay, so that's over here. I don't know why this did not stick to df2. It should. I probably just did something wrong. So df2. If I can't figure it out quickly, it doesn't matter. We're just gonna move on. So what we're gonna do is then just change the engine. So what I just showed you here is pandas, and now you can say run this on Spark, and then this now uses Spark SQL under the hood, and then gives you the Spark data frame.
That's awesome.
And then you can say Spark Fugue SQL Dask as well. And we have DuckDB. The Fugue SQL.
That's awesome for local big data, quote unquote. And I imagine Snowflake would love for you to do something like this too. I don't know how you actually execute it, right? Like on Spark, you must have written something in Java, I'm assuming.
Fugue DuckDB maybe. In Spark, there's already Spark SQL, so you just have to bring use Spark SQL. The transform is a keyword we added. So if it this is Spark SQL, this goes to like the Spark that we implemented, right? So
Right.
there's that
Right.
abstraction layer, and then I'll show you guys. I don't know how many like legit like nerds there are here, but I'll show you guys.
All of us. One of us, Kevin.
um, we have this over here in Fugue SQL. There's this grammar file, and this grammar file contains the grammar for the SQL.
Cool.
Right. So this is highly based off of Spark SQL's grammar file, but then like we added keywords. So for example, you should see a Fugue transform task, and then this transform is the one that adds the transform keyword on the Fugue data frame, and then it goes to the equivalent Python code, right? It's either, I think it's, no, it's not this. It's somewhere out here where there is the visitor, and then from there maybe there should be the visit transform. Oh no, it's not this file. It's the, no, though it should be this file.
That's cool though. That's really
Visit,
neat. Someone like Michael would appreciate this if you ever were to tune in.
So this is where the transform goes,
Cool.
and then it goes into the appropriate Python code, right? And then there's this workflow is the abstraction layer, and it uses the transform method, right? So that's how that works. So DuckDB, yeah, this is working now. So if you're not familiar with DuckDB is like just local execution, but they have stuff like lazy evaluation. So for example, if you query like from a Parquet file, they can get only the data that you need. So it's very optimized. So before DuckDB, like this is a pandas implementation that's written like on the Fugue level. But then DuckDB is like 100 times faster. So for local, you may as well just use DuckDB. And then you mentioned about Snowflake, right? So Snowflake is in the works. Like querying from Snowflake. Yeah, there's just a bit of because you know what's nice about Snow. So you know Spark has Spark SQL and Spark PySpark, right? And you know Snowflake has the Python interface now.
Well, they did Java UDFs first. Do they have a Python one now?
Yeah. It's like in like it's kind of like
ultimate technical preview. Yeah, they've been working on that for a while.
Yeah, Snowpark.
Yeah. Well, that's so Snowpark is what they call it. They started with Java. Yeah, do they have Python?
No, they do.
It's in preview for sure. Like that's what they're trying to do. Obviously, same thing with it's what PySpark is and Spark SQL too, and Delta Lake or whatever they call it, right? Which is like their Delta Lake. I think is Databricks, columnar thing.
So now if that's implemented in this, like if you say like Snowflake, you'll be able to use this. It becomes like a UDF on the Snowflake side, and then you can run it across your Snowflake warehouse, right? Yeah.
So well, that's really cool because then people they wouldn't have to necessarily choose between Databricks and Snowflake, even though that's what everyone wants. But you're kind of like abstracting between the two current appears to be winners of the infrastructure data warehouse wars.
Yeah, exactly. So like, same thing here. Like imagine we have this, I showed you this tag earlier, right? The syntax here is you would say like engine equals Spark.
Yeah.
Right, like that. And then this runs on Spark. So you could say like engine Snowflake. And then this whole thing would run as like Snowflake, right? And then you can also do like dag.run.
That's cool.
Yeah.
This is just all SEO. We're just going to say all the big vendor names. Do you have any other vendors that are hot you want to mention?
Ray integration.
Are you working on Ray integration? Ben Larica's gonna be proud.
Yeah. No, yeah, for sure. Like in the works. So Ray, like think about it, right? Because there's Modin already. So Modin, and I was gonna talk about Modin today. I still will if we have time. Modin says, hey, can you just change your pandas, import pandas as PD to modin.pandas as PD? and then we'll run your code on Spark or Dask. So we get compared to Modin quite a lot, because Modin is like, hey, I'm just changing my import and it's gonna run distributedly.
Is
right?
that all? Is that all you have to do? Is just change your import? That's it.
Yeah. I mean, yes, that's the premise of their project.
Right.
Yes.
Right.
So I have Modin as well. So you're gonna see there's I mean, yes, you can. So let's say our example here. We're
Kevin,
gonna bring
real quick too. Do you think that people would say, like they did the last time you were on, that your code is really neat for today?
No, this is a mess today. I'm sorry.
We'll take a poll in chat. Is Kevin's code neat today? Beautifully organized. Sorry to interrupt you, Kevin. I'm here to troll you. Continue.
I'm sorry, man. To whoever had that comment, I'm sorry I let you down. So here we say modin.pandas, and they said that everything should run, right?
Yeah.
And I think it does. So they say, hey, you just need to run this before you import Modin. Okay, so we're just gonna, import Ray, and then it should be good.
This may take some time.
Yeah. So and then there. So this is already. I think if I say what's the type of this, that it's a Modin data frame, right? So there is Modin. So
Henning says, by the way, neat code just means you've over-prepared, which I agree.
That's true. Yeah. Actually, I prepared stuff. We just didn't get there yet, okay? We just didn't get there yet. So that's what we're gonna be talking about, this Modin, right?
Yeah.
So I was on the podcast, on the data engineering podcast, right? And I got asked hey, what's the difference between Fugue and Modin, right? And there's like a whole like discussion about, like, we get compared to Modin a lot. But then to your point, Chris, like, because this is all pandas conforms to pandas already, and they execute on Ray, we could just add them as a backend, right? Because they already have all the functions needed.
Right.
And then, right, as long as it's performant and it makes sense, all we have to do is add another backend, and we could say like Fugue backend Modin, right? Like fsql.run Modin.
That's funny.
Right? why
Oh, I mean, it makes sense. It's nice and easy way of approaching that. Is your data engineering podcast episode up yet?
Yeah.
It is. So, I'll put a link in chat.
Yes. Thank you for. I don't know if anyone is asking, but if you are, thank you.
They had the DuckDB guy on too.
Oh yeah. So I mean, I'm not like. I made the introduction, but no, I mean, like, no need to be like. At the end of my podcast, Tobias was like, "Do you have any tools that you think I should interview?" I'm like, "Yeah, definitely DuckDB," because we were talking to DuckDB about a DuckDB engine. So I introduced. I made the introduction there.
DuckDB is hot on Twitter right now, by the way. I think over the last month or so, people keep saying, "Oh wow, this is great for local." Like you said, if a Parquet file kind of like unorganized, I just drop it in there and it's super performant. It's really interesting.
Yeah. Because think of it this way. Parquet is a column optimized format, right? So if you say like my Parquet has 100 columns,
right,
and I need 5 of them, I can just say load these 5 columns, and then the load only happens on those 5. But for CSV, you have to load that whole thing in, and then you cut out the 95.
Interesting.
Right? So DuckDB is like, it helps you, like pandas cannot like selectively cut out the 95, right, but DuckDB can, right?
Well, that's been the value prop of columnar databases for like 15 years though, since like Vertica, for example, right? But I guess you just had to have a large, heavy system. By the way, for first time chatter, DuckDB has been incredibly helpful for our local dev workflows.
Exactly. So the nice thing about Fugue and DuckDB is, like, if I do like this, DuckDB doesn't have transform, right? So what's happening under the hood here? This section executes on the DuckDB side, and then this section we bring to pandas for you, right? But then the important thing is you can now get you can define your full workflow in SQL, and we're the ones who run the Python side for you.
I mean, that's another really interesting use case for Fugue, I think, is that you don't necessarily have, it's not saying, oh, I have two different pieces of infrastructure for like in one area of my business, I'm going to use Spark, in another area, I'm going to use Dask. It's maybe even saying that I'm going to use DuckDB for local development. And then we're going to move into staging on something else. And then we're going to move into production on something else that's more expensive. It's interesting.
Yeah, exactly. So like this whole thing, you can also bring to Python land, by the way, by just using like this syntax. And import from, I think it's from Fugue SQL, import fSQL. Yeah. Oh my God. Oh, that's just because of the, again, this pandas data frame is getting, yeah. Okay, so yeah, that works, right? And then here you can say, hey, run this on Spark. So this also makes your SQL very testable. You can pull out the data frame. I just don't know the exact syntax on top of my head, but you could pull out this data frame and then you can run it later on. Yeah. So let's I think it might be yield. So yield input df yield data frame input df as let's say test. And this might, we'll try this on the local engine. Input df yield, I'm just gonna say yield data frame as test. Input df is not found. I just made it. Oh, I think I'll have to pass it. Okay, I'm not gonna bother with the syntax here. I'm not gonna bother. The import, because we're moving on to the next topic. The next topic is this Modin, right? And PySpark also has their own version, right? It's called PySpark Pandas, right? Import PySpark Pandas as man, I'm having too many of these guys now, so I'm just gonna like, this is MPD, this is KPD. Yeah, because okay, so PySpark Pandas is new in PySpark 3.2. Before that, it was a project called Koalas, and Koalas was the same concept as Modin. Hey man, just change the import of your your pandas code, and we'll be the ones to take it to Spark for you.
Interesting.
Right?
Interesting.
So, here now I can actually show the part that I prepared. So I am going to go over here, and let's talk about the difference of. So I'm gonna make a bunch of data frames. I'm just gonna copy this over.
And so, but I see this error, by the way. Is Modin using Apache Arrow?
In
some way.
No, this is the PySpark pandas.
Oh, okay, okay.
Yeah. But you know, like, so there's a bit to discuss here. So again, like the motivation for this and the motivation for the PyCon presentation is because Fugue gets compared to these guys, and we get asked like, how do you compare? Why can't I just use Modin, and why can't I just like why do I have to like use Fugue, right? Maybe we don't need the Dask one. Maybe, no, I'll just include it. So I'm gonna make a bunch of data frames. This is pandas. This is Modin. This is PySpark pandas, and this is Dask. And the first thing that we're gonna look at is actually I'm gonna. Oh, okay. First we'll just do a simple group by and just time everything, right? So I'm gonna do a group by on pandas. 15 milliseconds. And then we're gonna do the Modin one.
Okay. Wow, a lot longer.
Wow, that I may have flubbed something. No, that's unusually high.
Said Kevin with a smile.
No, that's unusually high. So you do get, I mean, it's not fair to compare these apples to apples because like this will be higher just because these are like this, they have distributed backends, right? And then this the one I haven't really figured out yet is Dask, which is blazing fast. Look at that.
Wow.
Look at that. And it does give me the output. I will, yeah, it does.
Is Dask already running? It's already running, right?
Yes.
Right. Yes.
Yes. And
don't worry.
Spark was as well. Spark was as well.
Huh.
So why is then Modin like? I mean, this is unusually high, but why is Modin like in general like slower than the others, or in general like why are they all slower than Dask, right? And the reason is look at this call, this pandas call, this reset index. Pandas is dependent on this index, right? And what does reset index actually do? So if you look at it again, index populates this, right? And what that lets you do now is you can say, I'm just going to call this df2. And now I can say, hey, get me the item in position 3. And then I get it, right? But what happens if you have a really big data frame? So our first data frame had a shape. I think I pressed something on my keyboard. Oh, no. I don't want to run all. Okay, so we're going to just run here onward. I thought I need the Ray init. 1 second. Okay, so I need this, and then this, and then this. Oh man, we're already out of time. But anyway, this is what I've been working on.
We can go a little over unless you have a 4 o'clock.
No, I don't.
We can go a little over.
Yeah. No, I have like 1 hour more.
We'll have you on again then.
So okay, so going back, let's try something else. Let's try the iLook operation, right? So what if I said, hey, get me the item in row 1000, for example. So in the df, it's gonna be like df.ilook. Let's say I'm gonna slice my data like this, and then I'm gonna say get me columns like value 1, value 2. I think this should work. Oh my god, something's up with like Spark and stuff. I'm gonna like reset.
It's that keyboard with no labels on it.
No,
I'm kidding. That's a joke.
I think it's because I'm running all of these like distributed frameworks and they're hitting each other. Okay. Let's go back here. So we have this. I don't have the Ray in it. I'm gonna copy it. 1 second. And then we have our data frames. Okay, so let's go back here. So let's say we want to get the item at a certain position. So for df, I'm gonna say, or maybe an easier one is maybe I have this already. I'm gonna sort the values and get the first 5 elements, and then we're gonna apply the time. So different use case, not quite the iLook yet, different use case. And we'll compare this. So we're gonna run this for all of our data frames again. Modin, Koalas will take some time, and Dask. So you're gonna find that pandas is like 25 milliseconds, and then supposedly the guys that distribute work, why are they all like a factor of like 10 more? And that's because they have to communicate. The sort has to now happen across the different workers, right? And then the sort, what you have to shuffle, what we call shuffle, when you have to move data between. so that you repartition it according to some like global value, right? And essentially that's what the index is, right? Because when you do reset index, you have a global order. And then now when you access the element in position something, you have to find it across the workers, right? So something we can show is that, let's take a look at we'll over here what we did was we we sorted and we got the top 5, but we're gonna change this just a little bit. What we're gonna do is I guess I'll conclude with this. What we're gonna do is sort the values instead. Oh, oops. And use iLoc to get a certain chunk, right? And see the timing of that. So in pandas, it actually doesn't make any difference because once you sort, you just pull, and this pull is already indexed. It knows where to find that, right? In Modin, on the other hand, okay, so it's just defaulting to pandas implementation. So this is something that Modin does, where like, hey, if the data frame, like if the operation isn't fully implemented in Modin yet, it can just use the pandas. So it converts everything, collects everything across all workers, makes it a pandas data frame on one machine, applies the operation, and then bumps everything out. And that's how they
at scale, that's not gonna be performant even. It's gonna have a compounding effect of non-performance.
Yeah, but that's how they fulfill the just change the import. That's how they do it. Yeah. And then this is a bit longer. And Dask. And Dask is the interesting one. It doesn't work. It's not implemented.
Ha! Look at that. That's fascinating.
Why is that? Because Dask must have realized that iLoc required a global order, and they made an intentional decision to not include it in the design.
Right.
So iLoc is actually limited to columns in Dask, but you can't do it on a row level, right? Whereas these guys, iLoc, they know iLoc is a very core feature of the pandas interface. So if their promise is that you can just change the import and it's gonna work, they need to commit to following that, right?
This is Spark, right? KDF is Spark.
KDF is Spark. Modin is the MDF.
Right.
Yeah. So now this means that whenever you have because like if you use the pandas interface, it's very common to say something like df.group by, I'm really losing the keys here. Group by .apply, and then .reset index. This reset index is a global order for this and for this, and that adds overhead to the operations. Whereas in Dask, they actually have a different definition of reset index. Reset index is applied for each partition. So from each partition, each worker, they just, or no, really each partition, they just go from 1 to n.
There's a unique index for the partition. Right. So, that's what you're saying. It's like it's unique to the partition.
Yeah, 1 to n for each partition.
Right.
But I don't know the order respective to other partitions.
Right.
Yeah. So if I do something like I sort and I get the 1000th element or something like that, Modin and Qualys can do it. But that's because they've committed to keeping that bookkeeping for every operation, right? And that's why but then if you think about it, like it's not like sometimes if you just tweak your code a bit, you can be friendlier to the system and not rely on it to like make these like kind of like not compromises, but add this overhead just so it can fulfill that interface, right?
Yeah.
So yeah, I have a bunch more, but I'm gonna end there. And then if anyone wants to hear more, my PyCon presentations next week. But I mean that's gonna be a while before that's published. Just message me, and I can definitely. I have more content around this that I can show. So I'll stop sharing there.
It's awesome. It's going to be fire. Really, really excited for your presentation at PyCon. We're back in Dexter's lab, by the way. Your presentation at PyCon. You always bring really interesting ideas, Kevin, which is why I love having you on PrefectLive. But like the idea that you can just pivot to, I think a lot of people just assume Python is Python. It should run the same no matter what you're using, but you pivot the type of thing that you're using in the implementation, and the interpreter essentially can drastically change. Like we saw Dask go from, 15, whatever that wasn't even milliseconds, to nanoseconds or whatever, to almost a full second and not implemented. It's just really funny. Yeah.
Yeah. So happy to chat more about Fugue or data frames in general. And then if anyone's at PyCon, hit me up. And then thanks to everyone for watching.
Yeah, very cool. Again, thanks for coming on. Thank you guys for watching. A lot of cool chat this week. And we'll see you at PyCon, and then we'll see you around next week on PrefectLive. See you guys.